Let's define a continuous random variable first. A continuous random variable, it's not countable, has an infinite number of possible values that can be represented by an interval on the number line. For example, the time that you spend studying in a day could be anywhere between 0 and 24 hours. Could be 1.1 hours, 1.2, 1.3, 1.4, 1.5, 1.6, 2.7, 2.8. There are infinitely many ways that you can represent, just the amount of time that you spend studying a day. Whereas if I tell you how many students do I have in my class, guys, that cannot be infinite. It's either a 0 or 1 or 2 or 3 or 4, all the way up to the maximum number of students. So the number of students is discrete, whereas the time you spend studying is continuous. In this chapter, we are only dealing with continuous variables. I like you to forget about discrete. Just worry about discrete when you do chapter 4. And once you finish with chapter 4, guys, forget about discrete variables. Now, in chapter 2, guys, you learned about this distribution. Let me just show it to you.
With the bell shaped.
Yes, exactly. That's what that chapter is about. You learned about this. This is the mean. And this is plus 1 standard deviation. We added 1 standard deviation. Here we added 2 standard deviation, 3 standard deviation, and then we subtract. For example, if the mean, guys, is 100 and the standard deviation is 15, let me just show you how to represent a normal curve. If you remember, we call that the normal curve, the bell-shaped curve. So this one, guys, will be 115. This value will be 130. This value will be 145. This will be 85. Minus 15 will be 70, and minus 15 will be 55. This is called the bell-shaped curve. Now we're going to give it a new name, which is called the normal curve. It is symmetric. The mean is the same as the median, is the same as the mode. The mean is usually right in the center. 50% of the data is below the mean, and 50% of the data is above the mean. The entire area under the curve, guys, is always 100%. And if you remember, guys, that we said, and you don't have to memorize this anymore because you're going to be able to verify it using technology. 68% of the data values lie within 1 standard deviation of the mean. And then if you remember, 95% of the values lie within 2 standard deviation of the mean. And then 99.7% of the data lie within 3 standard deviation of the mean. This is called the normal curve, the symmetric curve, and the continuous normal curve, because it only deals with continuous variables, not discrete variables. So this is the normal curve, guys. It is the most important continuous probability distribution in statistics, the normal curve. And if you ask me why, because most of the data that we collect, guys, if we try to sketch it, it will turn out to be like this. That's life. That's how it is. Most data that we pull, it turns out to look like this. Some properties of the normal curve, guys. The mean, median, and mode are, I just mentioned the word earlier. Equal. And if you want me to know where, they're right here, guys. The normal curve is bell-shaped and symmetric about the mean. That's what we just talked about. The total area under the curve is equal to what?
100.
100%, yeah. Or if you like, 1. The whole thing, the whole pizza, 100% of it. Okay, if you guys notice how I sketched the normal curve, I like it to look at it. I try not to make the curve touch here. But when you do use technology to sketch it, it looks like it's touching, but actually it's not touching. So the normal curve approaches, but never touches the x-axis. Just keep that in mind. Never touches the x-axis as it goes indefinitely to the right or indefinitely to the left. That's the normal curve. A normal distribution can have any mean and any standard deviation. Let me show you some figures, guys, how the mean and the standard deviation can change. Can you guys tell me, I'm gonna hide it here. Can you tell me what the mean is here?
3.5.
3.5. Exactly. And he tells you what the standard deviation is. It is 1.5. Now look at the mean here. It's 3.5 as well. But the standard deviation is lower. Do you guys understand why the standard deviation is lower in this curve than the other one?
The data is more consistent.
Yeah, how do you know that?
Well, I mean, because of the
shape
standard.
the shape of the curve.
Yeah.
This is narrower, this is wider. When the curve is wide, guys, that means the data is more spread out, so it's a larger standard deviation. Now look at those two curves, guys. Do you agree that they have the same opening? That means they should have the same standard deviation. So those two curves have the same standard deviation, but look, they have different means. And it's obvious why they have different means. Look, the mean here is 3.5, and I can see the mean here is 1.5 in the middle. So you could have any normal bell-shaped curve with a different mean and different standard deviation. That's what we're trying to show you here. Okay, I'd like you to do this exercise together now. Okay, which curve has a greater mean, A or B?
A.
I don't think I need to explain. I don't think I need to explain it. It's 15 and it is 12. The mean for curve A is 15 and the mean for curve B is 12. Okay, which curve has a greater standard deviation? You don't need to know what the standard deviation is to be able to tell. Just look at the shape of the curves, guys. Which one?
Has a greater.
Yeah. And if you are asked to explain, guys, you just say B, the data in B is more spread out than the data in A. It's obvious. You could see it's a wider curve. All right. Any questions so far, guys? So I just want you to have a visual of the normal curve. Anytime, guys, he mentioned a normal curve, here's how I like you to visualize it. Once he mentioned a normal curve, guys, just visualize it like this. Mean is right here. And then here, it's a mean plus 1 standard deviation, mean plus 2 standard deviation, mean plus 3 standard deviation, minus 1 standard deviation, minus 2, minus 3. For example, if he tells you the mean is 10 and the standard deviation is 2, so you should have here, guys, 10, 12, 14, 16, and then minus 2, minus 2, minus 2. That's your bell-shaped curve. That's the normal curve. All right. Now, I'm going to draw this normal curve, guys. with the mean, let's say 20, and standard deviation is 4. Okay, so I should have here in the center 20. This is what? Let's split it up. 24, 28, 32. You guys agree? Plus 4, plus 4, plus 4, and then minus 4. 8. Now I'm going to draw another curve, guys. And I'm going to ask you a question. Try to copy the exact same curve. I claim, guys, that those two curves are exactly the same. The only thing I change is, assume that this shape is exactly the same as that one. The only thing I changed the labeling. Can someone tell me what is the relationship between the labeling at the top and the labeling at the bottom? What is it that I did at the bottom? I changed the labeling to make it something different. What is that I did?
You changed the standard deviation and the mean.
What did I change them to? What did I change those values to?
On top it's only positive, but on the bottom is negative.
Yeah, but what are those? What are those?
These are standard deviations.
Just you changed it to a value of 1. Standard deviation, that's all.
So that's this value. Okay, do you guys agree with me that 24 is 4 points away from 20, which is 1 standard deviation? 28, how much is the difference between 28 and 20? 80 points. How many standard deviation is 80 points, guys? 2 standard deviation. Look, there is a 2. 32 is 12 points away from the mean, which is 3 standard deviation. I put 3. 16, guys, is 4 points below 20. And each 4 means 1 standard deviation. I put a -1, -2, -3. Do you still remember what we call those values? 1, 2, 3, -1, -2, -3. What did we call them in chapter 2?
Z-score?
Yes, z-scores. So here, these are the actual x values, guys. And here they are the z values, the z-scores. Okay. This one, guys, doesn't mean just number 1. It means a z-score of 1. That means the value is 1 standard deviation above the mean. This is 2 standard deviation above the mean. This is 3 standard deviation above the mean. If you ask me how come 20 became a 0, let me tell you how come 20 became a 0. Here's the formula for the z-score. Value minus mean divided by standard deviation. So if I want to change 20, guys, to a z-score, look what I do. You put 20 minus the mean, which is 20, and divided by the standard deviation, which is 4, so you get 0. That's why I put a 0 there. If I want to change 24, guys, to a z-score, look what I would do here. I put 24 here. 24 minus 20 is 4. 4 divided by 4 is 1, and that's why you see a 1. Let's say I wanted to change 12 to a z-score. You put 12 here, guys, 12. Minus the mean, which is 20. 12 minus 20 is -8. And divided by 4 is -2. And that's why you have -2. So, guys, this curve and that curve are exactly the same, but the x-axes are just labeled differently. Here we use the actual values. Here we use z values. And when your curve looks like this, 0, 1, 2, -1, -2, -3, this is called the normal curve. This is called the standard normal curve. So once you use z labels, you call it a standard normal curve. And that's what I wanted to show you right here. This is called standard normal curve. So a normal distribution with the mean of 0 and standard deviation of 1 is called standard. So the word standard means z-scores, guys. Normal distribution. Okay. To go, guys, from a normal distribution to a standard normal distribution, we change the values to z-scores, and that's what it says here. And this is the formula for the z-score. It's the value minus the mean, guys, look here, divided by the standard deviation. Okay, so now we know what a standard normal curve, which is 0. You put the mean is 0 and the standard deviation is 1, and you count 0, 1, 2, 3, 0, -1, -2, -3. They represent the same thing, but they just look different, you know, just on the horizontal axis. Okay. If I ask you guys to tell me what's the area to the left of z equals 0, can you tell me the answer?
50.
50%, that was easy. What about if I ask you the area to the right of 0?
50.
50%, okay, great. There's one other question I can ask you, you can answer it, but then after that, probably you won't be able to answer any of those questions. I think you should know what this area is, if it still rings a bell.
65.
Not 65, it's a little
68.
bit higher. 68%. Very good. This is within one standard deviation of the mean. Okay. Now let's make it harder. And now this is the beauty of chapter 5, guys. Again, I'm using Z. Watch, guys. I don't think you can tell me what the area is to the left of -1.75. If I give you 4 choices, guys, and one of the choices is less than 50%, and the other 3 choices will be more than 50%. Do you guys agree with me that your choice of the answer will be the one that is less than 50%? Do you agree with that?
Yes.
Yeah, because you know it's less than 50% because this is 50%. So my answer is definitely less than 50% for sure. But what is it?
0.3.
We'll see. You cannot guess it. It's impossible to guess it. If I put -1, 1, you would have guessed it because you know that was something we did in chapter 2.
That's 8% of the area.
How
About
do you know it's 80%? How did you know that?
because that number you can calculate it with the z-score calculator. I used it
okay.
last
You already
semester.
know about that. Very
Yeah,
good.
out of 100, that's the total area, and then
Yeah.
there's a way you
That's-
can calculate.
Yeah, we're gonna show you the techniques now of how to calculate the z-score. So just one